Okay, so this is the very first chapter in intermediate algebra, linear equations and inequalities, which are part of our first topic in section 2.3, absolute value equations. The absolute value of a number is the distance between that number and 0 on a number line. So the absolute value of -4 equals 4 because the distance between -4 and 4 on a number line is 4. We wouldn't say the distance is negative. You can't have negative distance. The distance between 0 and 5 on a number line is 5. So the absolute value of -4 is 4. The absolute value of 5 is 5. And notice how both of those numbers are positive. Absolute values are negative, never negative. Well, if an absolute value can't be negative, why does the definition of absolute value look like this? How's it possible that you could have this in the definition of absolute value? Okay, so absolute value of x could be x or it could be negative x. How is that possible? Well, if x is negative, like that -4 we just saw, then the absolute value of -4, as we just saw, was +4, but that's the negative of -4. So that's actually not negative, that thing that I circled. The solutions of an equation of the form absolute ax plus b equals c, a not equal to 0, c positive, are those values that satisfy ax plus b equals c or ax plus b equals -c. That's important because we often will have equations written this way, and we will want to solve them. Of course, you can't solve it if it's got the absolute value bars around it, and so we want to break the ax plus b, the inside, out of the absolute value bars. And this rule tells us that the equation is true if the inside equals c. It's also true if the inside, ax plus b, is the negative of c. Right? Because if all of this in here is -c, then absolute value is going to deal with that negative, and you're going to have the truth. Okay, so here's an example. Solve and check your solutions. Absolute value, z minus 15 equals 23. And so z minus 15, that is the inside. And according to this rule, if the inside equals c, where c here is 23, then you have the truth. Or the inside could be -c. So we're going to break that z minus 15 out of the absolute value bars. And one of the things that is meant by an absolute value statement is just drop the absolute value bars. So z minus 15 equals 23. But the other thing is that you drop the absolute value bars and make the other side negative. This is also going to be true if the inside equals negative 23 as given in this other result of the absolute value equation. So we changed the sign on that 23. Well, these two equations are extremely easy to solve. In either one, all you'll do is add 15 to both sides. Add 15 to both sides, z equals 38. Add 15 to the other side, and you have negative 23 plus 15. If you're $23 in debt, but you only pay back 15, you're still $8 in debt. So z equals negative 8 is also a solution to this equation. Well, we should check our solutions. So you put 38 back into the original equation. Absolute third, well, we'll check negative 8 first. Put negative 8 back into the original equation. Negative 8 minus 15, that's negative 23, the absolute value of which is 23. Our other solution, 38, clearly that's going to give you the truth also if you put it back into the original equation, which is the way we check things. Solve and check your solutions. So a similar situation, except here we have a fraction. Well, the excuse me for a moment. Okay, I'm back. All right, so we will basically run the same thing. The rule still holds whether a be a fraction or not. So we're going to break that 1/2 x minus 1 out of the absolute value, set it equal to plus or minus 5. Which means for both of these equations, it's the same algebraic moves always in these. Add 1 to both sides, and we're going to undo the 1/2 by multiplying both sides by 2, which is the same as dividing by 1/2. So add 1 to both sides to undo the subtraction by 1, and 5 plus 1 are 6, and then oh, it looks like we're clearing out the fraction first. Multiply both sides by 2. Multiply both sides by 2, we get x minus 2. As we distribute the 2, 2 halves make 1 whole. Now all we'll have to do is add 2 to both sides to get 12. But we do the algebra in parallel for the other equation, and we're doubling everything in that equation. So and we also get x minus 2, but if you double the negative 5, you get negative 10. In both of these equations, we'll add 2 to both sides to get 12, or negative 8 as the two solutions. The solution set negative 8, 12 as for this equation. Both solutions do check. Well, now we have a different form. That is, it's not just absolute value of something equals something, but there's also another addend outside the absolute value bars on one side. Well, in such a case, we're not quite ready to apply any rule about absolute value. We're going to use the same rule, as you can see, very same rule. It's not like the rule changes just because that 3 is there. What we'll do is get rid of the 3 and then use the rule. So subtract 3 from both sides. Now we have absolute value of something equals something. absolute d plus 7 equals just a number 5, and now we can apply the rule. The inside equals plus or minus the number. D plus 7 equals plus or minus 5. Same algebra in both equations. Subtract 7 from both sides. We get 5 minus 7 or negative 2. Negative 5 minus 7 or negative 12 as the solutions. And you, as always, you should verify that both check. Put negative 12 back into the original, and you get absolute negative 5 equals 5, which is true. Put negative 2 back into the original, and you have negative 2 plus 7, which are 5, the absolute value of which is 5. Well, here's a new kind of equation where you have absolute value on both sides. You've got absolute value of one thing, call it inside 1. I'm going to use a subscript here, 1, and then a different one here, inside 2. Inside 2. So absolute inside 1 equals absolute inside 2. Excuse me. I'm making a video. It's okay. So if you have absolute inside 1 equals absolute inside 2, okay, then that means that the insides are either the same or the opposites of each other. Okay, now why is that? Okay, you have absolute inside 1 equal absolute inside 2. That means inside 1 equals inside 2, or inside 1 is the opposite of inside 2. And that's true because if you think about it, if you had this rule, which is still true, now C is an absolute value, then you'd have to say break the ax plus b out of the absolute value. That's equal to the other absolute value, but then the other absolute value, which is represented just by this C here, is going to be equal to two things, right? Because then you're going to have absolute value of something, of an inside, equals something. That means the inside of that absolute value, represented in the C here, equals plus or minus something. Fortunately, and that would give you 4 equations, fortunately, you actually have 2 of the equations are the same and the 2 other equations are the same. So we're able to summarize this situation with just this relatively simple rule. It makes sense, right? If let me change color here. Let's go to this. If this ax plus b would be the same as this cx plus d, well, if you change the sign of one of them, and I'm talking about this equation here, if you change the sign of one of them, you're still going to have the truth because the absolute value will take care of that sign. On the other hand, if both of these, ax plus b and cx plus d, if those two things are the same, you're obviously going to have the truth. Example. We have inside 1 and inside 2. And so if inside 1 here is the same thing as this inside 2 over here, we're going to have the truth, obviously. But it's also true that if inside 1 is the negative of inside 2, that we also have the truth for that statement about M. Well, you need the parentheses to have the negative of inside 2, right? Otherwise, it's not the inside of 2. So don't do what some students do and call this negative 2m plus 3. It's the negative of the sum of 2m and 3, meaning you have to have the negative of the whole inside 2. Well, we're going to clear out fractions, multiply both sides by 2, and that's going to, in fact, we might even put parentheses here, double the entire right side. Again, same algebra in both, but here we multiply by 2 in order to get rid of that 2, and we just have the m minus 1. The 2 will distribute to the 2m plus 3, and that'll be 4m plus 6. In the meantime, we have added 1 to both sides to get rid of the constant 1 or negative 1 on one side. 4m plus 6 plus 1, that's 4m plus 7, but then we'll have to eliminate m from one side. So we'll subtract 4m from both sides. I'm going to make my little scale here. We're solving a linear equation, right? That's why this topic is in this chapter, because once you break the thing out of its absolute value bars, in these problems we are getting linear equations. Why is it linear? It's linear because m is being raised to the first power. M is raised always to the first power. That makes something linear. M, if you have a money, if you have one money and you subtract 4 monies, then you have a negative 3 monies, and that equals 7. And we're going to divide both sides by negative 3 to undo the multiplication by negative 3 and get negative 7/3 as one solution. Similar algebra on the other side. Multiply both sides by 2, and that's going to clear out the fraction 2 on one side, giving us m minus 1. Throw an extra factor of 2 on the right side and distribute the negative 2 to get negative 4m minus 6. Negative 4m minus 6. And you combine those constants. Okay, these are constants. They can be combined. Careful of the sign. It's going to be negative 5 because you're $6 in debt, but then you get $1. So negative 5. At the same time, we're adding 4m to both sides, and 5m equals negative 5. Isolate m by dividing both sides by 5. M equals negative 1. We have two solutions which we ought to check in the original equation. They both would check. Those are the solutions, and so those are the different kinds of problems that we have in 2.3. Absolute value of something equals a number. We might have to isolate the absolute value. We had that example, and now we have an example. Absolute inside 1 equals absolute inside 2. That means inside 1 equals plus or minus inside 2.